So, I'm Alon Horev, CTO at Vast. Thanks all of you for coming here. It's truly our pleasure to have you, and it's our first user conference. So for me, seeing a bunch of customers at the same place, cross-pollinating and sharing experiences and the things they do, it's a big pleasure, and it will become now an annual tradition for us. I'd like to present Scott Howard, subject matter expert for S3. In Vast, Scott, you want to share a bit about?
Sure. So, hi guys, my name's Scott Howard. I'm a field CTO for the APJ region, but mainly specialize on S3.
Okay, and we wanted to dig into S3 and talk about a bunch of different aspects around S3, not just performance or not just the protocol, and you know, kind of reflect on why it's interesting, why it's growing. This year was the year that Vast basically saw much higher growth in object versus anything else. And I think there's, I can understand why it's happening, and I wanted to share that with you guys. So let's start with a bit of history. AWS S3, right? The de facto standard for object. It's not the only implementation that you would have known about 10, 15 years ago. You also had Swift and a bunch of different products. Basically, building massively scalable systems is hard, right? And presenting primitives that are simpler, like saying, you're going to write objects, there's no renames, you can't mutate them, everything is immutable. It makes life easier for architects and engineers to build such systems. So it kind of forced, AWS to say, I'm going to do this way, and given anyone that would use the cloud, they kind of had no choice. They would have to use that as the only viable storage option, which is still true today. But because they also created a new protocol that's built for the internet, they also had opportunities to solve a lot of things that were historically hard with file systems. So, what does it mean to be like an internet-first protocol? It's based on HTTP. Encryption comes in as a big part of the story. Authentication, the security story around S3 is massive. Where file systems, if you look at NFS, or if you look even file systems that have higher levels of security, like SMB or using Kerberos, those mechanisms are never trivial, right? And as a user deploying an application, you're dependent on administrators, and we're going to talk a bit about. Scott is going to share more about the differences there in terms of the experience of deploying a workload. So internet first and security are very big pillars of that aspect. Another aspect, because again, it grew up in the cloud, is that you want to self-administer. You don't want to call the AT guy and say, hey, give permission to that user to access this directory, which it presented a lot of new primitives, bucket policies, identity policies, lifecycle policies. There's now a lot of richness within the protocol that allows the end user to do more. Right? Not necessarily calling anyone. In the days of the developers working in the cloud, anyone is a DevOps engineer. There's less and less delineation between those types of roles and responsibilities. And then comes the question is, how should you choose, right? So Scott, let me hand it over to you, discussing some of the trade-offs, and I'll take it away a bit later.
So, quick show of hands. Who here is actually using object or S3 object storage in your environments? Okay, so a couple. I actually asked the same question yesterday in a data store session, but I went through all of the different protocols. And as Alon mentioned, our S3 is now our second most used protocol. Not surprisingly, NFS is number one. S3 pretty much eclipses SMB in terms of the second protocol, and is catching up fast to NFS.
Capacity, by the way, with S3 is already higher.
Even more so, yeah, absolutely. Many of you didn't put your hands up there, but the simple fact is you do use S3. You use S3 every single day, because every time you go to the Vast Data website or any other website that you go to, you are using S3. Because as Alon mentioned, this is a HTTP protocol. This is a protocol that Amazon designed for their own internal usage for serving internet traffic, that then became a sort of public storage protocol. So the simple fact is every single one of us is using S3, almost every single minute of every single day on your phone, on your computer, and everywhere. Obviously, that's a little bit different when you start using it in a corporate environment, but it just shows that it's probably the most ubiquitous storage protocol out there at the moment. So most of you are using file. What's the difference between file and object? Very little, but at the same time there is actually quite a bit. So I'm sure everyone here is familiar with file storage, whether it's because you're using it on a vast cluster with NFS, whether you're just using it on your laptop. You have that traditional hierarchical storage of data, and you have at the lower level of that hierarchy, you have something called a file, and then that file will have a path to get to it that works from the top down. So in this case, this would be tom data 2.text. But really that string is more an instruction on how to get to that file within the hierarchy of the file system. Object is quite different, or at least S3 object, and most object protocols. Sorry. Traditionally, object has had a flat structure, and this is, for most people that have a view of how object storage works, this is what you think of. I have a bucket, and I put stuff in it. And the stuff in it generally doesn't have any structure. It doesn't, the names could be things that are in English. They're often hashes and things like that. But more and more, we actually see people wanting structure in object buckets. And although I can have an object with a name or a key, as it's called in the S3 world, of prices1, I can also have an object with a name of prices1.xls, which doesn't mean that that's an XLS file. Unlike file, where the extension might actually have some meaning, in this case, they're just all letters that are meaningless to the system, but meaningful to a human. I could also have sales / prices1.xls, which you would look at and think, well, that's a subdirectory, right? But it's not. In S3, they're all just characters. The / is largely meaningless, and it's still just a key for the object. Same if I had something like that. Now, S3 has added some concept of sort of directory, what they call a prefix, using those slashes as a delimiter. But internally to the storage, that is just a string of characters that defines an object. So if I look at the two of those, the S3 object name and the file object name, obviously they look very, very similar. So where does the difference come in? Well, the biggest differences between object and file is not actually anything to do with naming or anything like that. It's how the system works internally. Objects are immutable. What do I mean by that? You can't modify an object, or at least when I say object here, I'm referring to S3. There are obviously different types of object storage out there. Some do actually allow you to modify objects. Even some of the newer S3 or AWS S3 does allow you to, but as a general rule, objects are immutable. Once you upload one, you can't modify it. Obviously for a file, you can modify it. You can append to it, you can change data in the middle of it. With an object, you can't. Now that doesn't mean that you can't change the contents of that object, but the way you do it is by uploading a whole new object, a new version of that object that then replaces the old object. Probably the biggest difference, though, is that objects are atomic. And what I mean by that is, consider a file system. You start writing a file, and someone comes along to read that file while you're halfway through reading it. That user gets half that file. They get however much you've written. If they read a second later, they'll get a little bit more. The file will look a little bit bigger. With object, you don't get that. With object, the object either exists or it doesn't. And it exists in its final state or not at all. So if I upload a 1 terabyte object, it might take me a day to do it. That object just doesn't exist until I'm finished uploading it. And then the moment I finish uploading it, it's there and it's 1 terabyte in size. If there'd been a previous object with that same name or that same key, then that old version would have existed right up until I finished uploading the new version, at which point it takes over. So for anyone that's had to handle things like locking of files or creating a file in a temporary name and then move it to a different directory, this just removes that entirely as a problem. The system itself is going to handle the fact that the user always gets, the full, complete, latest copy of the object. I've already mentioned this one. Objects as a rule don't have a directory structure. Again, there is some, you can add the concepts of a directory structure there, but internally, the object protocols don't really care. And then I'll come back and dig into this one in some more detail, but objects have metadata, and they have metadata that you, as the user uploading an object, can actually set. But let me come back to that one. And then, as Alon mentioned, we have a lot of different options here for permissioning. Again, I'll come back to that in a moment. So again, as Alon mentioned, S3 is based on HTTP. And this makes using S3 quite simple. Anything that can talk HTTP can talk to an S3 server. Now, that doesn't mean that they can't do everything on that server, but they can at least talk to it. If you want to go and write a client to talk to S3, or you want to write an application to talk to S3, you don't have to sort of try and find a library that talks NFS or SMB or reinvent a client to do that. Any HTTP client's going to work. It also means that we get a number of the HTTP things for free. If I want to encrypt my data, then HTTP has a way of encrypting data, SSL or TLS. So S3 uses that encryption in the exact same way that any other website would do. Things like proxy servers and load balancers, if you have a need to use those, any web proxy server or load balancer will work fine with S3 traffic. The big difference here, though, is the authentication model. HTTP does not have a good authentication model. It's very basic. In fact, it's literally called basic auth. So that is an area that AWS reinvented when they came up with S3. So what's the difference when you actually, how does this actually manifest as differences when you're accessing a file or an object? So this is that path that I had before. We can see that the paths look very similar between the file and the object version. Let's say I want to access that file. What have I got to do? Well, I've got to mount the directory, which means I've got to go and find an administrator and get them to mount it because I probably don't have the permissions. And then I've got to get whoever runs my storage to give me the access to it to be able to do that. Then I need to, at least at the protocol level, I need to go to the prices directory, and then I need to go to the prices 2026 directory, and then the March directory, and the 06 directory, and then finally I can access that file. And maybe I only wanted to access that one file, so now I need to unmount my file system to clean up. Now realistically, obviously, you wouldn't normally do this, but if the goal was just a one-time access to a file, that's what you would have to do. Let's compare the S3 version of that flow. We would access the object. It's just a straight HTTP URL. We would download that URL. No mounting, no accessing, no sort of server credentials needed. We still have the authorization and authentication for the request, but that's just a part of that one single request. So depending on what you're trying to achieve here, either of these could be better. If I was accessing 1 million small files in a directory, then obviously for this flow here on the left, I wouldn't be repeating that process 1 million times. I'd do the first 5 steps once, and then access the files one at a time. It is actually quite efficient to do that over file. If I'm randomly accessing a file from a host that I don't have set up and mounted on my host, then obviously the S3 version is going to be easier. I don't need to have all of that overhead of setting things up. A user can just give me a URL or give me an S3, an object location, and I can access it. So depending on what you're trying to achieve, the S3 version here looks much simpler, and for the most part it is. But depending on the access patterns, either of them can be good. Over to you, Alon.
Okay. We get some questions from customers when they're considering S3. They're asking whether S3 is too slow for high-performance application, or even whether it's meant for archive. And I think it's really important to make a distinction between a protocol and an implementation, right? As Scott was saying, S3 is a protocol based on HTTP. AWS S3 is an implementation, right? And whether the underlying implementation has different hardware, SSDs versus hard drives, fast networking versus slow networking, how much firepower, how much compute. All of those make a world of a difference. Round trip time and link speeds are sometimes a big factor in terms of what the latency is for the applications themselves. So the reality is that we get customers to help us understand a bit about the workloads and what they're trying to solve for. But in general, there are very high performance workloads running on vast S3. Some famous models are being trained on S3 because some of the model builders that we work with were born in the cloud. They don't know another option. They started in Azure, they started in AWS. They built their tool chain and tooling and scripting around S3. And this is a reality that it works. Now, Scott is going to give you a bit more color in terms of the actual, trade-offs behind it, kind of under the hood. But the idea is that it can be built for high throughput. And you guys need to kind of understand the trade-offs to guide your users if you are trying to solve for high performance S3. Another aspect beyond the underlying hardware components is the architecture. I heard from a bunch of customers that some object implementations are very bad at listing metadata, basically listing buckets. Why is that? Maybe there's a single metadata server that can become a bottleneck for the entire cluster. Vast shards or partitions metadata distributes it across all the SSDs, so we don't have a single metadata server. So that's not a problem for us. So again, architecture makes a world of a difference. And then eventually, again, there's those guidelines that do matter, right? When folks are doing small objects, you are going to see a big degradation compared to file workloads because every single request gets authenticated and compared against various policies. And HTTP as a protocol is text-based. There's a bunch of textual headers that need to be parsed. That's a world of a difference compared to file or block workloads. Thank you.
Okay. So which is best, file or object? Well, as we've sort of covered, it could be either. It could, depending on the exact workload. But the joy of Vast is that we are multi-protocol. And the benefit of that is that you don't actually need to make the decision when you're laying down the data of which protocol you're going to use to access it. So whether it's NFS, SMB, or S3, and I'm presuming most of you have seen this diagram, probably seen it a dozen times already this week, but just in case anyone hasn't, internally within Vast, we don't store things as S3 objects. We don't store things as NFS files. We store them as what we call an element. And then that element is really a superset of all of the protocols. So you can write a file over S3, you can read that file over NFS or SMB, or any combination of those three. So the joy of this is that you don't need to make a decision to use, I'm going to use NFS for this workload. Maybe use NFS for writing files and use S3 for access to it. Or, use NFS for most reading, but use S3 for some. So you don't need to make those decisions in advance. And it's just a sort of fairly simplistic example of where we do see customers using this in the life sciences field. So systems like DNA sequences and X-ray machines and CT machines historically have written files using SMB. And it's ironically because they had a Windows 95 or Windows 3.1 laptop in there driving the system. So they used SMB. That's starting to change to S3 nowadays, but let's say it's SMB for that first step. But now that I've got that DNA sequenced or that X-ray file and I want to do some analysis on it or I want to do some inference or training on it, I don't want to be doing that over SMB. So by being multi-protocol, we can just access that file over the best protocol for each step of that flow. So I can process it over NFS, I can do some inferencing over NFS over RDMA. If my users want to view that X-ray and they're on a Windows box, well, they can use SMB to view it. So the joy is that we don't need to sort of pick the best protocol overall. We can pick the best protocol for each step of the process. Now, Alon mentioned high performance S3, and that is one of the areas that Vast is well known for. The place that we really started with doing high performance S3 was actually in the data lake world with Hadoop. So who uses Hadoop? No one. Interesting. Oh, yeah, I got a nod or two there. Okay, so Hadoop traditionally has used HDFS for its storage. HDFS, I guess, was good when it came out many, many years ago, but it's very inefficient. In most cases, you end up storing 3 or more copies of your data to get performance, to get resiliency. But Hadoop does also support using S3 for data storage. So we've had many customers that have migrated their workloads from HDFS onto S3. From Hadoop, it's a largely transparent operation because Hadoop natively supports S3, and I'll explain in a moment how it actually does that. And we end up getting some very significant data reduction savings there. The first obviously being just the fact that I'm not storing 3 copies of the data to get the resiliency. We get to use the built-in data protection resiliency within VAST. That's going to be significantly lower. We also generally get some level of data reduction on this data. Of course, the better way to do that is to move this data into a VAST database table, but we'll leave that for another session. So just as an example of actually one of our very earlier customers that did this, most of you in this room probably haven't heard the name Agoda. If you were from Asia, you definitely would have, because they're basically one of the largest travel companies in Asia. You probably all heard of Booking.com though, who owns Agoda. So they have many, many tens of petabytes of Hadoop data running on VAST very successfully using S3A. One of many, many customers that we have doing that. There's many of the newer big data applications are S3 native. So these, as Alon said a moment ago, these are things that were born in the cloud and natively speak S3. So again, work very well on VAST. And in some cases, we can even use these as multi-protocol. So being able to access that same data over NFS for some systems and via S3 for others, where it makes sense. Another one that's not mentioned there actually is Splunk. So Splunk Smart Store, classic example of an application that started out being file-based and is now moving over to using S3 for storage. So we do have a number of customers using Splunk on VAST. The other big use of S3 that we've seen pick up in the last year or two is, not surprisingly, for AI. And for a number of different areas of AI. And as was mentioned on the main stage today, checkpointing has been a big one here. NVIDIA added the ability to do S3 checkpoints a year or two back, or 18 months ago, I guess. And we now see a large number of customers using us for checkpoints. But it's not just for checkpoints. So we also see a lot of customers using S3 for training. And then Alon's favorite one is KV cache. So is a very big use case that we've seen recently. There was some mention today around visual language models and VSS, and so this is NVIDIA's VSS pipeline. So video summarization and search, and this is an entire pipeline based around S3. And why? Well, because as was mentioned on the stage this morning, with video, you're taking in a video stream, you're splicing it up into chunks, and S3 is just a perfect protocol for doing that, especially in a world like a vast data engine, where we're doing triggers based on those objects being uploaded. But even independent of VAST, the majority of the VSS pipeline from NVIDIA is actually based around using S3. Another big use case we see is backup and restore. So most of the backup vendors nowadays have at least the option, if not the preference, to save data on S3. And probably the biggest reason for that, part of it is because of simplicity. S3 makes it easier to do things like, maybe not exactly air gap, but to limit the amount of exposure that you need between your backup software and your primary environment through to the storage target for the backup. But the bigger reason is because of some features that S3 has around object protection. So predominantly something called object lock that I'll come back to in a moment. But object lock basically allows you to tell the storage, this object can't be deleted for a period of time. And that's great when it comes to backup and also ransomware. The common feedback we do get for backup is, do I really need flash for backup? And the simple answer is no, of course you don't. No one cares how long your backups take. The question you should be asking is, do I really need flash for restore? And the answer there is, hell yes you do. Because most of the backup software nowadays is, not just streaming out data, it's doing some level of dedupe and compression and other magic like that, which means that restoring from data becomes a fragmentation problem. And what you might think of as being a sequential workload actually ends up being a very, very random workload. And if you're storing that on disk, you're not going to get your data back quickly. And people don't care how long backups take, but people definitely care how long restores take. So, of course, not all S3 products are created equal. Obviously, there's the big data out there of AWS, where it all started. Although, actually, so technically, the protocol is not called AWS S3, even I end up making that mistake all the time. It's actually called Amazon S3. And the reason is because AWS really didn't exist when S3 was created. S3 was actually the first service that AWS released. So something to add to your history bit at the start.
That's very good. I didn't know that.
Yeah. So there are obviously a lot of different S3 products out there. AWS is the obvious one. There's a number of others in the cloud. There's a number of other products that do S3 on-premise. A lot of those products are not performance focused. They're more so for workloads where S3 started as being more of a dumping ground, more of an archive, as Alon mentioned, and they can be okay for that. But for the high performance workloads, we've got many customers now that have migrated off those various on-premises products onto Vast, just because of the complexity and the performance issues they get, especially as they start to scale. So the other big difference we see, this will do. So pretty much what I was just saying there, what if I don't need high performance S3 storage? So should I start using, should I start using cloud? Maybe. Cloud is a great way if you have a small amount of data to store. But I'm sure anyone that's tried doing anything in the cloud realizes that the bills might start low, but they have a habit of going up and up and up. With a lot of, maybe not some hidden costs, but costs that you just don't think of. I mentioned listing objects before. Every time you list the objects in your bucket, AWS will charge you. Every time you download an object, AWS will charge you. Every time you upload an object. Actually, they don't charge you for that, funnily enough. They're happy to take your data because they know they're going to be charging you further down the track. So, for very small deployments, yes, AWS can be a great solution, but watch the costs as it grows. On premises, as I said, there are many other products out there that can do S3. Most of them are just not designed for the scale that our customers are using S3 on. They're using things like multi-site erasure encoding and stuff like that, which ends up costing you often 50% or more overheads for data protection. Compare that to as low as 2.7% on Vast. But it's often a lot more than that. So I didn't want to pick on a product, but I will. MinIO, for example. If you write a 5K object to MinIO, you end up using more than 30K worth of storage to store that. And that's a combination of a few different reasons, but these systems generally just don't have the efficiencies that Vast has. So even though they might look like they're efficient, make sure you look at and do some of the math if you're looking at deploying any of those products, because the overheads can add up very quickly. And then I mentioned before, HDFS, openly admit that it's 3 times redundancy. So let's talk a little bit more about the S3 protocol itself. So there's a few areas, so we've mentioned a few of these as we've gone through, but areas where S3 sort of shines and is different to, is better than NFS. One of them is around security and authentication. There's a number of different ways that you can authenticate to S3, in the sense that there's actually one way you can authenticate, but multiple ways that you can get the authentication tokens you need to do that. So you can have permanent access keys, you can have temporary access keys, you can have one-time access keys, and this gives a huge amount of flexibility. This is why S3 is the protocol that runs all those websites that I showed before, because it gives you the ability to control who can access those things while still making it very open so that anyone you want to can access. Things like pre-signed URLs. So I had an image up there of Flickr, the photo hosting website. So Flickr uses pre-signed URLs for S3 for all of its images. But if you try and save those URLs so that you can embed your photos on a different website, that won't work. Because the joy of the way that pre-signed URLs work is that they will only work for a short period of time. So there's a lot of flexibility there in how these things work. We also have very fine-grained access controls. I'll come back to that one in a moment. And then, as I mentioned before, for encryption in motion, there's nothing to be done because we're using HTTP. HTTP supports TLS, so it just comes along for the ride. And then I've already mentioned this before, the networking topologies for S3 are very simple. We basically need a TCP connection. I need one port open to get to the S3 server and everything's going to work. We also don't have any sort of network discovery things. So, for those of you that looked at SMB and how it works, finding my Active Directory servers and things like that, none of that. At most, we need a DNS server to find my S3 server. So I mentioned that authentication has a number of options based around keys. And the way this is actually done is that the requests that you send are signed using one of those keys. It could be a permanent key, a short-term key, or a pre-signed URL. So this is one of those areas where AWS extended on top of HTTP, but did it using standard HTTP concepts. So the authentication header here, or the authorization header, is actually just a HTTP header within the request. But the actual content of that is very very S3 specific. For authorization, there's a number of different options here. So initially, AWS only supported ACLs, not dissimilar to what you have in a file world. You can give read permission, write permission, give it to certain users or groups. But over the years, they've expanded that considerably. And we end up with JSON-based policies like I have here on the right that can be incredibly powerful in terms of what you can do with them without requiring you to manage permissions at an individual object level. So in this case, I've got a policy here that's allowing read access to one group of users, write access to a different group of users, and then blocking another group entirely from a specific subdirectory, a specific prefix, to use the correct terms, and all objects within that prefix are going to be blocked from that group. The joy of these being JSON policies, once you get your head around how they work, they're incredibly simple to put together and incredibly powerful in terms of what you can do with them. So I mentioned metadata. So this is another one of the very big benefits of S3. So when you upload an object, you can send additional custom metadata with that. So there's two different types of metadata here. We have some metadata that is just used by the system. Things like a last modified header, things like which is actually a standard HTTP header. The etag header, which is a standard HTTP header. But notice there, the ones in blue, X, Amazon, Meta, and then some string after that. Those are tags that you as a user, when you're uploading an object, can set. when you download that object, you'll get that same metadata back. Now, in this case, we've got a mixture of different ones here. This S3B actually tells me that I uploaded that object using the S3 browser client, and whenever you upload something with it, it will automatically add some metadata to it. The SHA-256 is a hash of the object that I've uploaded. The color red is just a random flag that I decided to add. There's no rules here about what you can use this for. And then the content type image PNG is something that I got to set when this was uploaded and will be returned when it's downloaded, which means if I am accessing this with a web browser, it'll know that this is a PNG image and it'll try and display it. So the metadata that we're looking at here can only be set when an object is uploaded. If you want to change it, you need to re-upload the object with the new metadata. So it's fixed and immutable in the same way that the object itself is. There's a second type of metadata that's called tags, and these can be changed after the fact. So objects can have tags, buckets can also have tags, and these are just a key value pair like you see here. So I can tag an object to say that this object hasn't been processed yet. Processed equals false. Priority low. On VAST, we can set up to 40 tags per object. But unlike metadata, tags can be changed after the fact. So after I process this file, I can change those tags and set it to processed equals true. The tags themselves can be used for any number of things. For those of you that are familiar with VAST Catalog, and Andy gave a demo of that this morning, these tag data will actually be included in VAST Catalog. So you can actually search. You could search VAST Catalog and say, show me all of the things that are priority high but haven't yet been processed, and get a list of all of those objects. You can also mix the two concepts we've just mentioned, authorization and tags, and you can actually control who can download an object based on the tags on that object. So in this case, I've got another one of those JSON-based policies saying that this user can access this bucket, but I've got some conditions in that policy. And the first condition is that this policy only applies if the object has a tag processed equals true. So I can now have a situation where someone uploads an object, and until I've done whatever processed means on that object, no one, or this user, can't download it. But the moment I process that object and I change the tags on that object to process equals true, suddenly this user will have permission to access it. We've also got a few other conditions here. They'll only be able to access it if they're coming from one of those IP addresses or the IP range, and also only if they're using HTTPS. And there's a number of other things here you can set as a conditional.
If a user tried to access that file that had the rule, would he get a simple deny message?
You'd get a 403 and you wouldn't know why.
Okay.
You just don't have permission to access that file. It doesn't matter why. So you'll notice here this effect equals allow. So S3 works on the concept of deny by default. So you need to be given access to access it. So the question here was, what behavior would the user see if they tried to access this and it wasn't processed and they were otherwise allowed? Well, the deny would apply. It doesn't matter why they were denied. They would just get a denied 403. So this can be amazingly powerful in terms of how you can merge some of these different concepts together. We've got tags where we're just giving some metadata to an object, but now I can use that to control which users can access that object.
5 minutes.
Yep. I mentioned object lock before with backup software. So object lock is a standard AWS feature that allows you to lock an object so that it can't be deleted or overwritten. Now, it's actually a fairly complex feature. There's other features in AWS called versioning, where you can have multiple versions of an object, and object lock requires versioning. Object lock is a great feature where you've got software that uses it, and a lot of the backup software will. It will lock the object once it's uploaded, so that when the hackers get into your backup system and try and delete your backups, they simply can't. we actually came up with a simpler version of this, something we call indestructible object, which is similar but doesn't have the complexity that object lock has around versioning and the like. And with this one, you just say that for a specific bucket, you set a number of days, so let's say 14 days, and any object written to that bucket cannot be overwritten or deleted for 14 days. After 14 days, the object is still there, doesn't get deleted at the end of that time, but after that period, you can come along and delete it yourself. Event notification. So you've all heard about Data Engine, if only from the presentations on the main stage today and yesterday. Event notification is something that is a standard thing for AWS. We had to implement it a little bit differently to the way that AWS does, in the sense that we can generate an event when you upload or modify an object, so change a tag on an object. In our case, we send a message to a Kafka message bus. So this is actually the basis of the Data Engine product. Generating events when something happens, when a new object gets uploaded, so that we can process that. Obviously, there's a lot more to Data Engine than just that, but that's the basis of it. But you can also use this yourself. I was talking to a customer a few weeks ago who, every time an object gets uploaded, they generate a message event, and then they go and do some processing on that file. They don't set process to true when they're done, unfortunately, but otherwise they'd be a perfect example. So these events will happen immediately as soon as the event is, as soon as the action occurs, and they include all of the details of the actions. You know, which object was uploaded, or what was changed, which bucket it went to, etc. Replication. So this is an area that we do things a little bit differently to AWS by virtue of being an on-premises product rather than cloud. But our standard asynchronous replication does work fine for S3. So we can do this with as low as a 15-second snapshot cycle to get across to the other site. But more interestingly, we recently released synchronous replication for S3. So with this, we can have strong, consistent, synchronous, active-active replication between two vast clusters. So when a user uploads data to one of the clusters, it'll be replicated to the other cluster, and we will not acknowledge the upload back to the client until that data is safely stored on both of those clusters. So any reads will come locally from whichever cluster you send the traffic to. So there's zero performance impact for reads. There is a small performance impact for writes, or there is a performance impact for writes depending on the latency between the two systems, as you would expect, but generally quite low. In the interest of time, let me skip that one, other than just to say that we also support all of that standard vast functionality as well for S3. So things like multi-tenancy and snapshots, QoS, async replication that I mentioned, all of this works for S3 equally as it does for any of the other protocols on VAST. And then you saw this one mentioned on the main stage, S3 over RDMA, we're working on. Unfortunately, Jeff only gave me one of the two graphs, not the second one where it showed significantly lower CPU utilization. But if this is something that is of interest to you, this will be coming soon. Definitely let us know. We are looking for beta testers. And I think with that, over to you.
Thank you. Okay, let's zoom out a bit from protocol and features. I want to kind of reiterate some of the forces we see in the market that are pushing workloads, users, data sets towards S3. I think, first of all, every organization kind of fell in love with the flexibility that you have in the cloud and just provisioning stuff, right? Not necessarily needing to plan a year and ahead for many different siloed projects. Each one needs their own gear. What we see now is that when success hits, like you deploy a cluster and you can scale it linearly and you can throw more users and workloads on it, it becomes the default for the organization to put everything there, right? Because anything else becomes a snowflake. Like if you want your own dedicated infrastructure, you need a pretty serious justification. And if you can use the efficiency, say, of one vast cluster to host different users, workloads, data sets, everything becomes much more dynamic and flexible in the organization, like people got used to in the big clouds. So that's one, force, efficiency, right? The other thing is about acknowledging that data is useful and we want to share it more than we ever did, right? And being able to, look at your data as a data lake that different departments in the organization can consume. There's nothing simpler than HTTP and the policies that we mentioned earlier. Again, unlike file systems, where file systems by default, you need to actually know what network, what servers are going to be connected and mounted, and you want to have very fine-grained control over who's doing what. So that's the second thing. And the third thing is that many organizations today they span hybrid strategies across clouds, across data centers, across regions. And because they need to still move data from place to place, ingest data from devices, export data sets or results to their end customers, having an HTTP-based system enables that, right? So I'll give you an example use case that's very popular. Many of our customers are exposing S3 to the internet or whatever proxy they have, protecting their organization from the WAN, but they would still use S3 as the protocol that enables them to ingest data, to get data from cars, from applications, from users. And they perhaps then use NFS internally for training or just collecting the data and working with it. But S3 is a great protocol for ingress and egress. So that's the second thing. Now, what happens when you have all those workloads and users and data sets is that you now need multi-tenancy because you're kind of losing control over what's happening on the system. You gave users freedom, but you still need to be in control, right? So multi-tenancy for VAST, I'm just going to spend 60 seconds because we're done, but I would say that it's a very big deal for us because now that you're building an S3 system, you're losing control to some extent because you created a user, they can create a bucket. They can set their own policy on this bucket. So you delegated a lot of control to that end user, but you still want to be in control. So instead of admins and infrastructure teams managing buckets, they're actually managing tenants. And within a tenant, the end user, we call them a tenant admin, right? They can create other users, identity policies, create buckets. So how does the infrastructure team stay in control? We call them cluster admins. That's the type of the role in VAST. They can set quotas at the level of the tenant. That tenant can have 1 petabyte, 100 gigabytes per second, and 10,000 S3 connections. And then that team or department or use case can roam free within that tenancy and those limits. It comes with a lot of observability and tooling that's needed in order to actually understand what's going on. This is where there's metrics and Prometheus and Grafana and APIs if you want to automate everything. But we see that today as a very strong foundation. And the end user experience is that, again, you can have a user, they can log into VAST, they can see the UI, and they're only seeing their stuff, their users, groups, buckets, keys, and being able to expose all of the functionality in a multi-tenant fashion hasn't been simple. Today, it's our default. Everything that comes into the system as new is multi-tenant by nature. But it's a very big lift, and it touches every single aspect: performance, capacity, control plane, administration, networking. And it's been a lot of the work that we've been doing. And it's been very natural because every customer that builds an S3 implementation for the enterprise, it's just natural that it becomes a place where they want to dump everything. So yeah, multi-tenancy is a key part of it. Any closing words?
No, I think hopefully this was beneficial for people. We are a little bit over, but I think this is the last session of the day, so we can stay as long as we want if there's any questions.
Anybody wants to ask a question?
We do have a mic behind you.
I have a question regarding tags. So are those accessible somehow if I'm looking into the data from NFS?
Great question. So both tags and metadata, today we don't have a way to present them via other protocols. The reason being, of course, NFS doesn't have a concept of a tag. So we have been looking at using things like NFS v4 extended attributes to be able to do that. At this stage, we haven't done it. If you have a use case for doing it, definitely talk to us. We do, as I mentioned, have the ability to expose those via VAST catalog. So we do have some users that are using that as sort of a way around that. Rather than using S3, they can query the catalog and get the tag data there.
So this basically means if I will have some access control based on tags, this data will not be available via NFS.
Yeah,
whatsoever.
so I didn't have time to go into sort of how we work with cross-protocol security, but if you have a rule like that one I had there before, that will apply across all protocols. So if you tried to access that file over S3, it would be denied if it was, hadn't been processed yet. The same action would occur over NFS. If you tried to access it over NFS, you would not be able to access that object. So our security model, what we call security flavors, we enforce the exact same access controls regardless of which protocol you use. It's part of our multi-protocol implementation. And that in itself can be very powerful because we actually have some users that will use things like the identity or bucket policies like I showed before simply to control NFS access, because it's easier to write and understand a JSON document like I had up there than it is to try and understand the permissions on 1 million files in a directory under NFS.
Thank you.
Thank you. I think was there someone else there. Yep.
Hi. A question about before we were telling about the nConnect plus multipath for NFS. What about S3? Can I send data to multiple CNodes?
That's a great question. So achieving high performance with S3, the client libraries, the SDKs are actually pretty good at uploading data. By default, if the file is beyond a certain threshold, the client will do what's called a multi-part upload. So it would take the part, break it into pieces, and actually send a bunch of concurrent requests. From that perspective, it's quite similar to nConnect. On the read side, you actually need to work harder from the applicative side. Currently, I'm not familiar with a way to...
Same concept. So HTTP has a concept of being able to split a file, download a file in multiple parts. So not all clients will do that, but if you need high performance, then you can use a client that does.
So no multipath,
So in effect, it is multipath built into the protocol.
but against a single CNode.
No,
No?
no.
Okay.
So both multi-part upload and range downloads, you can spread across literally every C node in the cluster.
Okay.
Now, there are some complexities to doing that, and certainly if you have a need for sort of single object ultra high performance, then definitely talk to us and we can make sure that we've got things set up right to do it mainly on the client side, also on the DNS side, so that we make sure that the client is using multiple C nodes. But S3 by its nature is designed for high performance via parallelization. So you do need to have that parallelization. If you're just using a single stream, you will get nowhere near the full performance of any S3 system, but especially VAST.
Okay, thank you. If I can.
Yep.
Do you have any recommendation about the number of objects in a single bucket?
No.
Fantastic.
Yeah, we recommend we have, I think the largest single bucket I've seen is over 10 billion objects in a single bucket. But there's no reason we can't support 10 or times that or more. I would recommend on any S3 product, use prefixes to break them out. You don't want to have 1 billion objects in a single bucket, and that's because Alon mentioned before, listing performance. There's two reasons that some products have bad listing performance. One is because the implementation may not be great at it. The second is the S3 functions to list all my objects are fairly inefficient. So you actually need to list 1,000 objects at a time. So if I have 10 billion objects, divide that by 10,000, I need to make 10 million API calls to get all the objects. But if you break it out into prefixes, then you can sort of walk down that directory tree, even though there isn't a directory tree, but you can sort of walk down that tree much easier.
It also forces the users to organize their data in a certain way. And then it's useful because all the policies that we've shown, right, the permission-based policies, you can use those prefixes to reason about, how is my data organized? Who gets access to what? You can then create quotas on prefixes, snapshots on prefixes. A lot of the vast features that can apply to hierarchy can suddenly leverage that hierarchy. Even though the S3 protocol doesn't necessarily leverage it, you can leverage it as someone that looks at from high at the entire infrastructure.
Last one. In other products like Swift or Ceph, it's convenient to put a load balance in front of the system. Is the same for VAST or we don't need it?
You don't need a load balancer unless you have a specifically good reason. Okay, I'll give you an example. If the DNS-based infrastructure does not, it's impossible to disable caching, and you end up hitting one C node because there's DNS caching, right? But it's pretty rare. I'm not seeing implementations.
The main time we see people using load balancers or proxies is if they're presenting the VAST cluster out to the internet. And often it's just security dictates that they can't have direct connections coming in, and often it's easier to publish a single IP on the internet. But yeah, it's not needed, it's just often used for that use case. Any other questions?
Yeah, on that question, I was so let's say I have 50 C nodes and I have 1,000 clients, right? So I know the C nodes inherently don't load balance even NFS connections today. So how do you, even if I have a DNS round robin and I say, okay, you do the round robin, you still run into a single C node doing much more connections than the other one.
The joy of S3 is, in the use case you mentioned, with 1,000 clients, it will naturally balance itself out. So our DNS server, for S3, we would configure it to return maybe a dozen IP addresses for every single request. So every one of your clients, and it's not even clients really, it's like each request that they're going to make, they're going to get 12 different IPs. And that will just, the nature of randomness means that will balance out fairly evenly. The harder use case is I have one client. And one client generally won't want to connect to 50 or whatever the number you said was of C nodes, but that's where we do have some alternatives we can use.
So are you saying that with a single HTTP, let's say it's a GET request, the cluster will give them 12 IPs to talk to from the S3 side?
Yeah, and that presumes though that your client will use them. So this is, like I said before, it depends on the exact use case.
Okay.
The way that you would want to configure things is different if you've got one client downloading very large files versus 1,000 clients downloading all randomly. But we would look at the workload and we have answers that will work very well. And some of them do include using a load balancer. We've got some cute little tricks with using IP firewalls rules on Linux boxes to cause it to balance across all the nodes. It just depends on the exact use cases, which is best. And normally we don't need to worry at all. But for some of the very Hadoop, for example, some of our Hadoop customers would put some of these systems in place to balance it better, to get the best performance.
So these are configurable values. These are not out of the box, right?
Yes.
Okay, thank you.
This gentleman here was, you're nearer. You.
You had tagging and whitelisting via IP. Will it also work with an OIDC provider, via groups or something?
So the way so we can do OIDC not so much with the tagging side. So that was on the authorization side. On the authentication side, we support what's called STS, which is the security token service. Our implementation of security token service uses OIDC. So your user or your application would authenticate to OIDC, gets back a Java Web Token. It then sends that to our STS service, and it gets back a temporary access key that's tied to a role, depending on what the administrator set up. And then that temporary token will work for a period of time for whatever it's been given access to. And that period of time can be 15 minutes. It can be, I think, 36 hours is the maximum. It might be 12 hours.
A couple questions. First, do you guys have a recommended application to have users browse the S3 bucket, from a CLI? We use S3 CMD. We have Hadoop users.
Yeah.
And Scott, I think you actually helped me with one of the things where we were doing bucket policy. I forget. It was we had to make ACL private. We had to set ACL private to do something. I don't know. It's kind of buggy, but it's nice because it's a wrapper and people could do CP and all this other stuff without having to do the direct S3 calls.
S3CMD is the command that we use in all our documentation, and the reason is it's quite simple. So it's easy to understand, it's easy to use, it's good for documentation. It is really bad, really poor performance. So it doesn't do any form of multiplexing, any form of multipathing. So it will never get good performance. But for basic stuff, it's a good tool. The one I normally use is the AWS CLI commands. They work fine, and they have the advantage that they support absolutely everything. In fact, they support far more than we support because they support every AWS command, including managing EC2 and everything else. But they are quite complex to use. You sort of need to understand the actual S3 APIs to use a lot of the commands there. I haven't found anything particularly better from the command line. There's a good one called S5 CMD.
Yeah, it's like the new one.
It's very limited in what it can do, but it's written in Go and it's insanely high performing. So if you want the best performance from just a single client from the command line, Windows or Linux or Mac, S5 CMD is the way to go. I wish there was something better. Yeah.
MC's pretty decent too.
MC's not bad. Be cautious with MC just around licensing and the like, depending on what you're doing with it. But if you're using it internally, you should be fine. In case you're not aware, if you go to the MinIO GitHub repository right now, you'll find it is now officially dead. So, yeah, well, the open source version is like the GitHub repository is now being closed down. So hopefully someone will fork it and we will keep a open source MinIO because, as much as I recommend using Vast, MinIO is great for just, I need a quick little S3 deployment somewhere. Did they? Yeah, I'm sure probably 20 people have. The question is, which one will survive?
We're going to build the binaries and whatnot.
Excellent. Yeah, so
Also, another thing for CLI commands, I found good success with Arclone.
Yeah, so Arclone's a good one actually. So Arclone, for those that haven't come across it, it's a cloning tool for copying data. It supports like 100 different sources and destinations, one of which is S3. Actually, I think 2 of which is S3 because they have AWS S3, they have S3 compatible. They also support Azure and then file and NFS and all sorts of different things. And it is also very high performant. So it's not good as just a general client, but it's great for copying data. Absolutely.
One more quick one.
Yep.
So multiplier upload, if I'm doing it from one client, right, you're just threading it. You're not, VS isn't doing anything on the back end to balance it between C nodes, right?
So the problem with S3 when it comes to balance and these questions around multipathing and the like is that is not a function of the server. Now, it is to the extent of like the DNS responses that I mentioned, but it's multi-part upload and how many IPs you send it to and thus how many C nodes and whether you do the parts in parallel or one after the other like S3 CMD does, which makes it largely pointless. That's 100% driven by the client. So our recommendations are to set our DNS server to return at least 8 IP addresses, and then most good clients will use those 8 IP addresses for multi-part upload. So AWS CLI, Arclone, S5 CMD, all of those will take those 8 IPs, and if you've told them to do 8 or more threads or uploads in parallel, then yes, they'll open 1 to each.
Right.
But if you use S5 CMD, it will pick the first 1 IP address and it will do single threaded. It doesn't really matter, it's only using 1 because it's single threaded.
Yeah, so we're doing simple DNS round robin. And for NFS, right, we're using NConnect, so we're opening multiple TCP connections. But for S3, it's like doesn't have...
Depends on the client.
Yeah, exactly. Okay, thanks.
Yeah. Often it's not even the client so much as the client library.
Right,
like,
exactly. That's the
this
thing.
one's using libcurl, this one's using Bodo. They'll act differently.
Just to go back to the authentication / authorization topic. So you mentioned that you do plug in with OIDC providers. What about OPA servers for authorization?
Sorry, what servers?
OPA servers. So they would like to do something like Rego policies to federate access, fine-grained access control.
So the way to do that in an S3 world is through STS. STS is insanely flexible. And then we would use, today we only support OIDC for the actual control around that, for the the authentication side. But then when you use STS, you can apply I think I've gone blank on the name. There's something policy that basically limits down. So I can give you an STS temporary key that can literally do one thing and that's all, and expires in 10 minutes. Or I can give you one that is God mode and lasts for 12 hours.
Right, but the decision making that powers that, right?
Yep.
To decide whether you're gonna, let's say, vend credentials that are short-lived for 15 minutes, that have super user access or not. The decision making part, how does that?
So that is up to whoever is making it's down to the configuration on the cluster and whoever is making the call.
Okay.
So let's talk afterwards because we are very much over time. So I think we'll wrap there. Alon and I will both be around after. So if you've got any other questions, feel free to come up and we'll happily answer them for you.
Thank you so
Hopefully
much.
this was beneficial. Thanks for coming and hope you enjoyed our first ever user conference.
Thank you.
Which I think is now officially over.